Hello friends, welcome back to my channel Engineering Mathematics DJ Ganit. In this lecture we are going to discuss about another continuous probability distribution which is known as gamma distribution. We will see what is gamma distribution and how it is defined and what are the applications of gamma distribution. So before going for gamma distribution, we will require the knowledge of gamma function which we have discussed in the mathematics 1 or calculus subject. So if you are not familiar with gamma function, you can visit my mathematics 1 playlist and there you will find out the video lectures on gamma function. So we just recall the definition of gamma function which we require to define gamma distribution. Suppose alpha is any positive real number, then the improper integral of first type with limits 0 to infinity and improper integral of e raised to minus x times x raised to alpha minus 1 integral with respect to x. This improper integral is a function of alpha because we are integrating with respect to x, and it is known as gamma function of alpha, and it is a special function and we are using this notation for gamma function of alpha. So we will remember this gamma alpha is given by improper integral 0 to infinity e raised to minus x times x raised to alpha minus 1 dx, and we will require certain properties of gamma function also. First property which we can write is, if we are interested in the gamma function of alpha plus 1, then that can be written as alpha times gamma alpha. Similarly, if we are interested in the gamma function of alpha plus 1 where alpha is integer, then this is simply alpha factorial if alpha is natural number or positive integer. This is valid for any alpha positive real number, but in particular if alpha is a natural number, then gamma alpha plus 1 will be equal to alpha factorial. For example, if we are interested in the gamma function of 31, then this I can rewrite as gamma function of 30 plus 1, and using this property we can write this directly as 30 factorial. So we will require all these things in this topic of gamma distribution. Also, whenever we will require gamma 1/2, we will directly write gamma 1/2 equal to square root of pi. So with this in mind, we are able to define gamma distribution. So before defining gamma distribution, we just recall exponential distribution which we have discussed before this gamma distribution. We have uploaded 9 lectures of exponential distribution in the playlist of probability and statistics subject. So we just recall that what is exponential distribution and what is the PDF of exponential distribution. So we know that exponential distribution is used to model the waiting time until some event occurs. If we consider the random variable capital X as waiting time until some event occurs, or waiting time until first event occurs, then this random variable denoted by capital X is an exponential random variable. Exponential distribution is used to model the waiting time until some event or first event occurs. So here x is the exponential random variable, and probability density function of exponential random variable x is given by fx equal to lambda times e raised to minus lambda x for x positive and 0 otherwise, where lambda is the average number of events per unit time. Lambda is the average number of events per unit time. And using this probability density function, we can answer the probabilities related to exponential distribution. Now suppose we want to generalize this random variable up to any event. Here we are considering the waiting time until first event occurs, but suppose we are interested in the waiting time until second event or third event or 12th event occurs, then this exponential distribution does not work. Exponential distribution works for the waiting time until first event occurs, but if we are interested in the waiting time until say alpha-th event occurs, where alpha starts from alpha is greater than 1, that is alpha can be 2, 3 and so on. So if we are interested in the waiting time until alpha-th event occurs, then comes the role of gamma distribution. So here we will keep in mind that if we want to model the waiting time until alpha-th event occurs, where alpha is positive real number, it can be any positive real number, then we require gamma distribution, and for alpha equal to 1, gamma distribution will be equal to exponential distribution. So the situation in which we are interested in modeling the waiting time until alpha-th event occur, we will use gamma distribution. Now gamma distribution is also a continuous probability distribution, and it is generalization of exponential distribution until alpha-th event occurs. So whatever PDF we will define, that PDF must give you PDF of exponential distribution if we consider alpha equal to 1. So the PDF of gamma distribution is given by fx equal to lambda raised to alpha times gamma alpha x raised to alpha minus 1 e raised to minus lambda x, where x is positive real number and this alpha and lambda are also positive real numbers, and 0 otherwise. So if it is other than a positive real number, value of fx is 0. So here alpha is the number of events for which we are waiting to occur, and we can see if we take alpha equal to 1 in this formula, we will have lambda raised to 1, that is lambda divided by gamma 1. Gamma 1 is always 1. This is x raised to 0, that is 1, and we have lambda times e raised to minus lambda x. If we take alpha equal to 1, we will have fx equal to lambda e raised to minus lambda x, that is the probability density function of exponential distribution. So this is the probability distribution of gamma random variable, and here we are using this gamma function. We are considering gamma function of alpha, where alpha is the number of events which we are waiting for. Alpha is the number of events for which we are waiting, and this lambda is the rate of events, that is average number of events per unit time, and this alpha is known as shape parameter and lambda is called rate parameter. So here we have two parameters, alpha and lambda. Alpha is known as shape parameter, lambda is known as rate parameter. Alpha is the number of events which we are waiting for, lambda is the rate of events happening or average number of events per unit time, and this PDF helps us to model the waiting time until alpha-th event occurs, and for alpha equal to 1 we obtain exponential distribution. So whenever they ask you the definition of gamma distribution, we can write in this way, that a continuous random variable x is said to have a gamma distribution if the probability density function of x is given by fx equal to lambda raised to alpha divided by gamma alpha x raised to alpha minus 1 e raised to minus lambda x for x positive. Alpha and lambda are also parameters and they are always positive and 0 elsewhere. So I have written all these things here, that alpha and lambda are called the parameters of gamma distribution. Alpha is the number of events and is called shape parameter. For alpha equal to 1, we get exponential distribution. Lambda is the rate of events and is called rate parameter. Lambda is the average number of events or mean number of events per unit of time. And one more thing, if this alpha, which is shape parameter, is an integer, suppose alpha is a natural number, or if alpha is an integer, then gamma distribution is known as Erlang distribution or Erlang distribution. So when alpha is integer, gamma distribution reduces to Erlang distribution. And these are the some situations or applications of gamma distribution. Gamma distribution is a continuous probability distribution that models right skewed data. There are some data which are not symmetrical or which are not having normal curve shape. Their frequency curve or their probability density curve is different from this bell shaped curve. So this is not, we cannot apply normal distribution if our probability density curve is not in this shape or it is not normal. So whenever we have this type of skewed data, that if we have this type of data right skewed, that is our density curve has a longer tail towards the right side, then we are applying gamma distribution. So gamma distribution can be applied to those type of data which are right skewed. You can understand in detail about skewness on my lectures of basic statistics. There I have discussed about skewness of a data or skewness of a distribution. Gamma distribution can be used to model cancer rates, insurance rates and rainfall. Gamma distribution can also be used to model failure times, wait times, service times, etc. The most frequent use case for the gamma distribution is to model the time between independent events that occur at a constant average rate. To model the time between independent events, suppose events are alpha, that is alpha number of events that occur at a constant average rate, which we denote by lambda. Using gamma distribution, analysts can specify the number of events such as modeling the time until the second or third accident occurs. If we are interested in the modeling of the time until second or third accident occurs, then we must use gamma distribution. Gamma distribution can model the elapsed time between various number of events, whereas exponential distribution can model only the time until the next event, such as the next accident. That is the difference between gamma and exponential distribution. Now if you recall, we have discussed two forms of PDF for exponential distribution. We have discussed that exponential distribution has two different forms for its PDF, lambda times e raised to minus lambda x if x is positive and 0 elsewhere. And if we are using another parameter, say beta, then if we take lambda equal to 1 over beta, we have this PDF for exponential distribution, 1 over beta e raised to minus x over beta, where x is positive and 0 elsewhere. So here also for gamma distribution we have this type of two forms for its PDF. If we are using alpha and lambda, then we know that fx has this form, lambda raised to alpha over gamma lambda x raised to alpha minus 1 e raised to minus lambda x for x positive and 0 elsewhere. And if we take lambda equal to 1 over beta, then this PDF will change two parameters alpha and beta. It is 0 elsewhere. And if I take lambda equal to 1 over beta, here I will have 1 over beta raised to alpha times gamma alpha, and this is as it is, x raised to alpha minus 1 e raised to minus x over beta. So we will remember this also for gamma distribution. Either we can use parameters alpha and lambda, or we can use alpha and beta to write down its PDF. So whatever is given in the question, we can use that form of PDF. If we are given in the form of alpha and lambda, we will use this PDF for gamma distribution. If our question is containing parameters alpha and beta, we will use this form of PDF for gamma distribution. And the relationship between lambda and beta is lambda is given by 1 over beta or beta equal to 1 over lambda. In both the cases, alpha is same. It is known as shape parameter, and here we are using lambda. Lambda is called rate parameter, and lambda is equal to 1 over beta or beta equal to 1 over lambda. So beta is known as scale parameter. So this form of gamma distribution is called shape and rate form of gamma distribution. This distribution is also known as shape and scale parameter form of gamma distribution. So be careful if your question is having parameters alpha and beta. If they specify that these are the parameters, and if they give you the values of alpha and beta, then use this PDF of gamma distribution, or you can convert it in this form by taking beta equal to 1 over lambda or lambda equal to 1 over beta. So you can use any form of gamma distribution as per your convenience, but you must be familiar about these two different forms of gamma distribution. Different books are considering these two different forms in their literature, so we must be familiar with both the forms of gamma distribution. So that also I have mentioned here. Another form of gamma distribution, this is the form which we have used for defining gamma distribution. And if we take beta equal to 1 over lambda, or lambda is replaced by 1 over beta in this formula, then we obtain this form of gamma distribution. And here alpha and beta are parameters of gamma distribution. Beta is called scale parameter, and it is the mean waiting time. Beta is given by 1 over lambda, and lambda is nothing but average number of events occurring per unit time. Lambda is the average number of events occurring per unit of time, and we are considering beta equal to 1 over lambda. So beta is the mean waiting time between the occurrence of events. Beta is the reciprocal of 1 over lambda. So if your question is giving you the average number of events occurring per unit of time, then you have to consider beta equal to 1 over that number, whatever number is given. So be careful whenever we are using alpha and lambda. Alpha is the number of events for which we are waiting. Lambda is the mean rate of occurrence during 1 unit of time. And again we can discuss that how to decide parameters for a given problem. For that we use this example. Suppose we are interested in measuring the time between accidents in days. So we are interested in modeling the time between accidents in days. Therefore we can use gamma distribution, and it is given that suppose one accident is occurring every 4 days on an average. So here our random variable is the time between accidents, the time which is given in days between accidents. So we have to decide that what is the appropriate value of lambda or beta for this particular problem. So it is given that one accident is occurring every 4 days on an average, and lambda, if we are using this shape parameter, then lambda will be equal to average number of events. Here events are accidents, so we are interested in the average number of accidents per unit of time. Here unit is time is given in days, so we must decide lambda, which is average number of events per day, and here it is given that one accident occurs every 4 days. So we can decide that how many accidents will occur per day. So for that we can consider this type of thing, that for one accident is occurring every 4 days. So here I have written days and number of accidents. So if there are 4 days, number of accidents are 1. So if we are interested in the number of accidents in one day, then how many? So that means there are 1/4 accidents occurring during one day. Therefore lambda for this example will be equal to 1/4. So be careful, you have to decide that what is lambda and alpha for your problem. So always remember, lambda is the average number of events, or for this problem average number of accidents per day. Here it is given that one accident is occurring every 4 days on an average, but it is not given that how many accidents are occurring on an average per day. Here we have to decide lambda, which is average number of events per unit of time. Here time is given in days, so we have to decide that what is the average number of accidents per day. So that we can decide from this information, that if we have 4 days, number of accidents are 1, therefore there are 1/4 or 1/4 accidents occurring during one day. That suggests us to consider lambda equal to 1/4. So if we are using this lambda as a shape parameter, then we will use lambda equal to 1/4. But suppose we are using scale parameter beta, then we will consider beta equal to 1 by lambda, and that will be equal to 4 days. So be careful, whatever parameter you want to use, either shape or scale parameter, you have to decide values of lambda and beta appropriately. Alpha will be same for both the PDF, either we are using lambda or beta, but we have to decide lambda and beta appropriately. So always remember, lambda is the rate of events. Rate of event means average number of events per unit of time. So from your question, you have to decide what is the average number of events per unit of time. That will give you the value of shape parameter lambda. And if you want to use parameter beta, then consider beta equal to reciprocal of lambda. So here I have written lambda equal to number of accidents during one day, that is 1/4, and beta is nothing but 4, that is the time between accidents. So beta is the scale parameter and it is the waiting time between events. So beta is the waiting time between, mean waiting time between events. So here lambda is 1/4, therefore beta equal to 4, that is time, mean time between accidents, or we can say that there are 4 days between accidents on an average. So if we are able to decide lambda or beta appropriately from our question, then we can easily answer the questions or probabilities using gamma distribution. The main thing is how to decide shape parameter or scale parameter from the given distribution, if we are interested in using the PDF in the form of alpha and lambda, we must decide lambda, which is average number of events. This we must remember per unit of time. And if we are interested in using alpha and beta, we should decide mean waiting time between events. Beta is the mean waiting time between events, or beta is given by 1 over lambda, or we can remember simply lambda only. Beta is nothing but reciprocal of lambda, that is 1 over lambda, and we can use appropriate form of gamma distribution wisely. So this is all about gamma distribution. In upcoming lectures we will discuss questions related to gamma distribution, and we remark that they ask sometimes probability distributions of probability functions of this type of distributions. Here in summer 2022 there was one question about probability function of exponential and gamma distribution. They have asked you to write the probability function or probability density function of exponential and gamma distribution. So as we know, we can write down PDF of exponential and gamma distribution, and for our conveniency again we write down PDFs of exponential and gamma distribution. For exponential distribution, fx is given by lambda times e raised to minus lambda x. If x is positive, lambda is also positive, 0 elsewhere. And PDF of gamma distribution is given by lambda raised to alpha divided by gamma alpha x raised to alpha minus 1 e raised to minus lambda x. Here x is positive, alpha and lambda are also positive real numbers, and it is 0 elsewhere. So either we can write this lambda alpha parameters, or we can write the PDF in the form of alpha or beta. So this question was asked in GTU summer 2022. You have to just write down the probability functions of exponential and gamma probability distributions. Here lambda is the average number of events per unit of time, either for this or this, and here alpha is the number of events which we are waiting for, and if alpha is 1, this reduces to exponential distribution. So this is all about gamma probability distribution. We have discussed how gamma probability distribution is defined, what are the different applications, and how we can decide the parameters from the given question for our gamma distribution. So I stop here. Thanks for watching.